هذا هو جافي، عنكبوت عملاق يقال إنه يسكن أعماق غابات الكونغو. يزعم العلماء أن
There is a
عنكبوت
rule in biology that nobody is supposed to break. Spiders are not allowed to grow past the size of a human hand. It is written into the physics of their bodies, into the way they breathe and the way their legs work. And yet, in the deepest, wettest, darkest part of Central Africa, people have been describing the same creature for over 100 years. A spider large enough to take down an antelope, strong enough to build traps out of silk that behaves more like rope than thread, and old enough that some researchers believe it never should have survived into our century in the first place. For decades, this was treated as nothing more than campfire talk, a story told to keep children away from the tree line. But the more you dig into it, the harder that explanation becomes to accept. So the question isn't really whether the story is entertaining. The question is whether we have been wrong to laugh it off. And if we have, what does that mean for everything else we assume we already know about the Congo? To understand why something this size could stay hidden for so long, you first have to understand where it supposedly lives. The Congo Basin is not a forest in the way most people picture a forest. It is closer to an ocean made of trees, spreading across roughly 1.5 million square miles of Central Africa, second in size only to the Amazon. Large sections of it have never been surveyed on foot by outside scientists, and even now, with satellites orbiting overhead every 90 minutes, huge stretches of that canopy have never been meaningfully studied from the ground up. That matters more than people think. Satellites are extraordinary at measuring temperature, tracking storms, and mapping coastlines, but they are nearly useless against a triple canopy rainforest. The top layer of leaves is so dense in places that daylight barely reaches the floor, and heat-sensing cameras struggle to separate one warm-blooded creature from the thermal soup rising off millions of acres of decomposing plant matter. Drones fare even worse. Battery life, canopy interference, and sheer distance from any charging station make deep incursions nearly impossible. In practical terms, the forest floor of the central Congo remains one of the only true blind spots left on land. The terrain itself reinforces the isolation. Rivers loop and fork unpredictably, swamps swallow trails within a season, and the ground beneath the leaf litter can shift from solid to sinking without warning. Expeditions that would take a single day on open ground can take a week here, if they succeed at all. This is not an environment built for casual exploration, and that has consequences for what we assume we know. We've been surprised before. In 1901, European naturalists finally confirmed the existence of the okapi, an animal local hunters in the Ituri forest had described for generations, a horse-sized, striped-legged relative of the giraffe that Western science had dismissed as folklore until someone finally produced a hide. Just decades later, fishermen off the coast of South Africa hauled up a coelacanth, a fish scientists were certain had gone extinct alongside the dinosaurs. Both cases followed an identical pattern, local knowledge insisting something existed, and Western institutions insisting it couldn't, until the evidence made the argument for them. The Congo, more than almost anywhere else on the planet, keeps producing exactly this kind of correction. Long before any outsider wrote the name down, the Baka people of the region had a word for it, J'Ba Fofi, which translates roughly to Great Spider. It isn't spoken the way people talk about ghosts or monsters meant to frighten children into obedience. It's spoken the way you talk about a leopard den or a stretch of river with crocodiles in it, as a simple, practical fact about the landscape, something you plan around rather than something you fear in the abstract. Elders use the term to teach younger hunters which parts of the undergrowth to avoid. Trackers pass along descriptions of burrow entrances and silk markers the way you describe a trailhead. And what stands out to anyone who studies these accounts closely is the consistency. Communities separated by hundreds of miles of forest, speaking different dialects, with no shared media and little regular contact, describe the same animal down to specific details. A body somewhere between deep brown and near purple, a leg span reported at 4 to 6 feet, and a hunting method built entirely around patience rather than speed. According to these accounts, the creature doesn't chase. It waits. Descriptions consistently mention a burrow dug into the forest floor, its entrance disguised beneath a woven mat of leaves and silk. Around the opening, threads run outward like a tripwire net, coated in something closer to yellow resin than typical spider silk, strong enough, according to the stories, to hold a struggling duiker, one of the small forest antelope common throughout the region. When something brushes against those lines, the vibration travels straight to the animal waiting below, and it emerges fast enough that witnesses often describe the attack as instantaneous, more like a trapdoor snapping shut than a chase. None of this reads like an exaggerated campfire tale designed to entertain. It reads like a hunting manual, passed down because getting it wrong has consequences. Stories like this exist in every culture, and skeptics are right to point out that oral tradition alone rarely satisfies scientific standards of proof. But the J'Ba Fofi has something most cryptid legends don't: a documented account from an outside witness with no obvious motive to lie. In the late 1930s, a British colonial administrator traveling with his wife through a remote stretch of what was then the Belgian Congo reported an encounter that neither of them discussed publicly for years afterward. Their vehicle had slowed on an unpaved track cutting through dense brush when something large moved out of the tree line ahead of them. By his own account, his first instinct was that he was looking at a small animal crossing the road, a genet, maybe, or a young forest cat. It was only as the shape moved fully into view that the scale of it became clear: a body roughly the size of a large dinner plate, sitting atop legs that together spanned somewhere between 4 and 5 feet, dark and coarse-haired, moving with a fluid, almost liquid quickness that didn't match its size at all. He reached for a camera. By the time he had it raised, the animal had already registered the vehicle's vibration and vanished back into the undergrowth, leaving him with nothing but his own description and his wife's confirmation. She, by most accounts, was far more shaken by the encounter than he was, and reportedly asked to turn back rather than continue deeper into that stretch of forest. What makes this account worth taking seriously isn't drama. If anything, it's the opposite. Neither of them ran to a newspaper. Neither profited from the story. It surfaced only later, told in the understated, almost apologetic tone typical of colonial-era travel writing, from people whose reputations depended on being seen as level-headed. Scattered reports from other travelers and surveyors working the same region around the same period echo the general shape of the story, if not the detail. Something large, something fast, something no one could get a clear photograph of before it disappeared. Taken alone, an eyewitness account proves very little. Taken alongside a century of matching testimony from people who live in that forest year-round, it becomes much harder to file away as simple misidentification. If something like the J'Ba Fofi is real, it cannot simply be an ordinary spider scaled up. The engineering required doesn't work that way, and it's worth walking through exactly why, because the obstacles are genuinely serious. Start with the skeleton, or rather the lack of one. Spiders rely on an exoskeleton, a rigid outer shell that has to support the entire animal from the outside in. A garden spider's shell works fine at a couple of inches because the physics of small bodies are forgiving. But biology runs into what's known as the square cube law the moment you try to scale that body up. As length increases, weight increases by the cube, while structural strength, determined largely by cross-sectional area, only increases by the square. Take a 2-inch spider and stretch it to a 5-foot leg span, roughly a 30-fold increase in length, and you don't get a spider 30 times heavier. You get one closer to 27,000 times heavier, supported by legs that were never built to carry that kind of load. Under a standard arachnid body plan, those legs should simply buckle. For a creature like the J'Ba Fofi to move at all, its exoskeleton would almost certainly need to be structured less like a typical spider's cuticle and more like a genuinely engineered support system, thicker in cross-section, reinforced along specific stress points, closer in function to natural armor plating than to the thin shell of a house spider. It's not impossible in principle. Nature has produced comparable feats before. But it would require a very different architecture than anything currently catalogued. Breathing presents an equally hard problem. Spiders don't have lungs in the way we do. Most rely on structures called book lungs, layered folds of tissue inside the abdomen where oxygen passively diffuses into the bloodstream. That system is efficient at small scale and increasingly incapable as body size grows, because passive diffusion simply can't move enough oxygen fast enough to reach the interior of a large body. This is precisely why, during the Carboniferous period roughly 300 million years ago, dragonflies grew to the wingspan of hawks and scorpions grew to the size of large dogs. Atmospheric oxygen levels back then ran significantly higher than they do today, making that kind of passive respiration viable at scale. Modern atmospheric conditions don't offer that same advantage, which means a creature the size of the J'Ba Fofi would need either a drastically more efficient respiratory system than any known spider possesses, or a genuinely unusual local environment. Deep, humid, stagnant valley air pooling at unusually high concentrations, to make up the difference. Then there's the matter of how spiders actually move. They don't rely on muscle contraction the way we do to extend their legs. They use hydraulic pressure, pumping hemolymph into the limb to force it outward. It's an efficient system for something the size of a coin. Scaling that same hydraulic system up to a 5-foot leg span would demand a circulatory engine capable of generating and sustaining enormous internal pressure, something closer to an industrial hydraulic pump than anything found in the arachnid world today. None of this rules the creature out. It does strongly suggest that if it exists, it isn't simply an oversized version of a species we already know. It would need a genuinely different physiology, a different respiratory strategy, a different structural design, possibly even a different evolutionary branch entirely, dressed in a familiar shape because that shape happens to work exceptionally well for an ambush predator. Skepticism about a 5-foot spider becomes a lot less automatic once you look at what nature has already managed to produce without anyone's permission. The Goliath bird eater, native to the rainforests of northern South America, holds the current record for the world's largest spider by mass, with a leg span that can reach roughly a foot across, genuinely close to the size of a dinner plate. It's large enough to prey on small vertebrates, equipped with fangs capable of piercing skin that a house spider couldn't touch, and it thrives in exactly the kind of humid, layered rainforest environment the Congo also provides. It is, on its own, proof that the upper limit of spider size is not nearly as fixed as casual assumption suggests. Then there's the coconut crab, a land-dwelling arthropod found across parts of the Indian and Pacific Oceans, which can grow to nearly 3 feet across and weigh close to 9 pounds. It breathes air, climbs trees, and has claw strength powerful enough to crack open a coconut shell or kill small birds. It isn't a spider, but it demonstrates something important. An armored, land-based invertebrate can reach genuinely large size and still function, still breathe, still move effectively, provided the right ecological conditions are in place: isolation, abundant food, and minimal competition from large predators. That last part matters specifically for the Congo. Certain regions of the basin have historically supported lower densities of large cats compared to other parts of Africa, leaving something of a vacancy near the top of the small to mid-size predator hierarchy. Ecologists have a name for what tends to happen in that situation, a kind of evolutionary opportunism where an existing species expands to fill an empty niche, growing larger over generations because nothing is competing with it or hunting it down before it gets the chance. It's the same basic principle behind island gigantism, where isolated populations with abundant resources and few predators grow dramatically larger than their mainland relatives over time. An isolated forest basin the size of a small continent, largely undisturbed for millions of years, is about as close to a giant ecological island as you can get without actual ocean involved. None of this proves the J'Ba Fofi is real, but it dismantles the idea that its size alone makes it impossible. Nature has repeatedly shown a willingness to build exactly this kind of animal, given enough isolation and enough time. A common argument against the creature's existence is simple. If it's really out there, why hasn't a trail camera or a smartphone caught a clear image of it by now? It's a fair question, and the answer has more to do with biology than conspiracy. According to the accounts, the J'Ba Fofi is fundamentally a subterranean ambush predator, spending the overwhelming majority of its life inside a burrow rather than moving openly through the forest. Most wildlife photography, whether from a hiker's phone or a professionally placed trail camera, depends on catching an animal in motion across open or semi-open ground. A creature that spends 90% of its existence underground and only surfaces in brief, targeted strikes is almost purpose-built to avoid exactly that kind of documentation. There's also a more technical wrinkle. Many trail cameras rely on infrared illumination to capture motion at night without spooking the subject with visible light. But a wide range of arachnids are known to be sensitive to wavelengths in or near the infrared spectrum, meaning a camera designed to be invisible to the human eye may not be invisible at all to a spider. If that's the case here, an infrared trail camera wouldn't just fail to capture the animal. It might actively warn it away, functioning less like a hidden observer and more like a glowing sign reading exactly where not to walk. Scattered pieces of second-hand evidence have surfaced over the years regardless. Logging crews reporting thick, oddly structured webbing draped across sections of canopy, workers describing a low clicking or hissing sound from the undergrowth at night that closely resembles the leg-rubbing warning behavior documented in known large tarantula species, just apparently louder and closer than anyone expected. None of it rises to the level of hard proof. But it fits a consistent pattern rather than a random scattering of unrelated noise. There's a term ecologists use for places like the Congo Basin, a refugium, a region stable enough, climatically buffered enough, to let older lineages persist largely unchanged while the rest of the world goes through ice ages, mass extinctions, and dramatic shifts in climate. Sharks and crocodiles are the textbook examples, animals whose basic body plan has barely changed in tens of millions of years simply because it already worked, and nothing forced them to abandon a winning design. If the J'Ba Fofi is real, it may belong to that same category, an ancient lineage that found a stable, effective niche deep in one of the most climatically consistent environments on the planet, and simply never had a reason to change. Complicating matters further is the fact that spiders fossilize extremely poorly. Their bodies are almost entirely soft tissue, and in the acidic, waterlogged soil common throughout the Congo, that tissue breaks down before it has any real chance of leaving a trace. An entire lineage of large, ancient arachnids could theoretically persist for tens of millions of years without leaving behind a single fossil for anyone to find, invisible not because it doesn't exist, but because its own biology erases the evidence almost as fast as it's produced.